Hiya, in the last video we had a look at some solvings of cubics for some relatively straightforward ones, as you can see here in these three examples. Check the previous video out if you can't remember. In this video we're going to have a look at two more examples, and they've started to get a little bit more tricky. So let's start off with example 4 here. X cubed minus 19x plus 30. Now, don't be put off by the fact there's no x squared term in this. That's okay. We can sort that out. We just need to start looking at different possible values of x that we can put into this equation to make this equation equal to 0. So in other words, we need to effectively use the factor theorem. So if we can prove using the factor theorem that when I put a value in for x, the result is 0, then x minus that value must be a factor. Here we go then. So one thing I just thought I might point out, and I think I did it in class, but I'll just do it now as well, is that in terms of which factors we have to look at, its factors are 30. So I can look at 1 and 30, I can look at 2 and 15, I can look at 3 and 10. I'm just doing factor pairs, but it's not like 1 times 30 because it's going to be 3 factors. I can look at, let me see, 4, 5, and 6, and I think that's all the factors we've got there. So these are all the possible numbers that we can try using the factor theorem for. So if I start off by setting p of x equal to x cubed minus 19x plus 30, I can now just start using values. And by the way, you have to use positives and negatives here because you may end up with a negative times a negative equaling a positive. So I start off with p of minus 1, and I get minus 1 cubed minus 19 multiplied by minus 1 plus 30. That's definitely not equal to 0. So as soon as you can see it's not going to be equal to 0, you don't have to worry. And I'm actually just going to go p of 1 is not likely to work either for the same reason. It's just not going to get us up to 30. So I'll have a go at something more. I'll have a look at p of 2 and see how that goes. I'll go with positive 2 to start with, just to see what it's like. I haven't done this problem before, by the way, so I am just working it out as I go along with you. Minus 19 times 2 plus 30. Now, this looks like it might be a possibility. 2 cubed is equal to 8, so that's fine. Minus 19 times 2 is minus 38. Plus 30. Yep, that works. I was thinking for a second, which is why I was pausing. Oh, maybe I should have tried negative 2 to start with. But no, 8 minus 38 is minus 30 plus the 30, which is equal to 0. Therefore, x minus 2 is a factor. Great. Once we've got one factor, we can now have a crack at factorizing the rest of it. So I might just go onto slide 6 for that because I think I need the room. So it's an x cubed, which means I need 3 columns. So just do our reverse box method, split it into 3 columns, like so. I've got an x cubed here. And I know what I have to finish off with. I have to finish off with a 30 at the end there. And I know that x minus 2 is a factor. So I'll pop x minus 2 here. Okay, so x times what equals x cubed? Well, the answer is x squared. And therefore we've got minus 2x squared here, minus 2 times x squared. Looking at the diagonals there, if you have a look at the original equation there, it's x cubed and minus 19x. There are no x squareds. Artificially, that means I've got a 0x squared that I need to aim for. So what I have to do to get from negative 2x squared to 0x squared, I'm going to have to add 2x squared. Okay, so just the opposite. Now I'll fill up the top there. So x times positive 2x equals 2x squared. And now I'll fill the bottom box up by saying minus 2 times 2x is minus 4x. Looking at the x term there, I need to get to minus 19. So I've got a minus 19 here, which means that I need to have a minus 15 here, like so. x times minus 19x, beg your pardon, and a minus 15x here. So that means I need a minus 15 here. Minus 15 times x is minus 15x, and minus 15 times minus 2 is positive 30, and that is the final term. So that's a tick there to say that that's definitely worked out. And so what do we have? We have it equal to x minus 2, the first factor, multiplied by x squared, plus 2x minus 15. And that is our almost factorized expression. Let's have a look at x squared plus 2x minus 15. And again, we can do it by reverse box method or some sort of grouping method. We could even use this method again if we really wanted to, but I'm going to do it by inspection, I think. So I need to find two numbers that will multiply together to give me minus 15, that will add together to give me positive 2. So I can see that that would be positive 5 multiplied by negative 3. 5 3s are 15, and 5 minus 3 is positive 2. So that's just by inspection, we call that. So that's going to be x minus 2, x plus 5, x minus 3 are my three linear factors. Remember, it's not always linear factors. So now I can say, and that's equal to 0. So therefore, by the null factor law, I have x equal to 2, x equals negative 5, and x equals 3 are my three possible solutions. Remember, it's not always three solutions, but it's at most three solutions. Okay, this video has probably gone on long enough, so I'll leave it there for example 4. You can have a go at exercise 6D question 4, and come back for the next video where we'll have a look at another example.